Part C asks us when or what values of x on the interval from -2 to 5 does g have a relative max? And then justify your answer. In other words, give a reason for your answer. Well, we know that a function has a relative max when its derivative changes from positive to negative. So if we go back up here, we have the graph of g prime, and we can see clearly that the derivative changes from positive to negative right there when x is equal to 2. So that'll be our answer. X equals 2 because g prime, which is equal to f, changes from positive to negative. Part D, we want to know when is g concave up. Function is concave up when its derivative is increasing. So we need to go back to our picture and determine when that function is increasing. Here's our picture. We can see the function is increasing at the beginning until it reaches x equals 0. Then the function decreases for a while, and then the function increases again at the end from 3 to 5. So from -2 to 0 and 3 to 5. Those are the two intervals in which the derivative is increasing, so we're going to put those down. -2 to 0 and 3 to 5. And again, we need to justify our answer. What's going on? Because g prime, which equals f, is increasing. And when the derivative is increasing, the function is concave up. All right, last but not least, we have h. h is equal to the integral from 0 to x of f of t plus 2 dt. And we are tasked with finding h of 4. So h of 4, that's going to be the integral from 0 to 4 of f of t plus 2 dt. So perhaps because we are adding here, we can use our properties and we can break this up. This is equal to the integral from 0 to 4 of f of t dt plus the integral from 0 to 4 of 2 dt. Now the integral from 0 to 4 of f of t dt, we found that out already. We did that back in part B. We know it's equal to, whoops, where am I? There we go, pi minus 1. Right. So this part is pi minus 1. Now we have to do the integral from 0 to 4 of 2 dt. We did this earlier with the definite integral properties. Again, what we're interested in is a function where we're always equal to 2. And we're interested in that region from 0 to 4. So that region ends up being a rectangle with a base of 4 and a height of 2. The area, therefore, between the curve, which is the blue line, and the x-axis would be 8. So there's our answer. If you want to make it plus 7, that's fine. The quick way to get this 8, by the way, is to just look at the difference between the bounds, 4 minus 0 is 0, and multiply it by the number in the integrand. 2 times 4 gives us our 8.